Hello, friends. This is the most Java coding interview cracking channel. If you really put on effort to practice this code solution, you build a confidence to easily code in front of every Java interviewer. Now, these are the most frequently asked questions by every interviewer. It is Stream API. What makes this channel special is I explain the functionality of the code line by line. I'm gonna explain it line by line. So this is, as I told you, it is Java 8 Stream API, my first video, but in the next video I'll record a very advanced Java 8 Stream API. Now, I have collected all the codes in one place so that you can see how I execute this code, and also so that you can practice very well. Now, without delay, let us continue, and happy coding. The very first code is to create a comma separated starting from a list. As you see here, this is a comment. This is a comment that says it's a requirement, a kind of requirement to create a comma separated string from a list or a string. That is the requirement. Is using Java 8 streams. You can use the collections dot joining method, to achieve this. This method. So as I here, let me see this. Let me take away this comment, so that we can execute the code. Also here, okay, here you see, create a list of names. Here in my first code, you see the code, the line, my first line, list, string, names. List is from the collection, as you all know that, Stream API is used to process a collection, right? The array list and list and map and other collection interfaces, So here, list string names. This is the reference. Names is the reference. Arrays as a list. Here is the input John, James, Tom, Mark. These are strings. So create a list of names here. In my this first line creates a list of names. What about the second line? String word names dot stream. This second line, you see this second line, this line, what does this line do? Convert the list to a stream and join elements with commas. You convert the list to a stream. This is the line that converts to the stream. Then join elements with commas. This is the method, you see, joining, that this line in this bracket, you see this comma. In this comma, you can replace any other delimiter, but here it is comma. So you will see when we execute this code, you can execute in different, not only comma, but you can do any delimiter. So the last the last line, this line, you see this line is this printing the resulting comma separated string. This is to print, system dot out dot println. That's the word. This is the stream reference. So the output we expect here is John, James, Tom, Mark, separated by comma. This is the requirement, comma. You have to separate them, comma. So let's execute this code and see what happens. Let me run this code here. Okay, you see here, John, comma, James, comma, Tom, Mark. So it is as expected. So forget about this number 2. This number 2 is from the other block of code that is not commented. And one thing I want to notice is here, you see, we are using comma delimiter, right? But what about like use dash? Yeah, you can have the same. We can separate with dash. You see here, John dash, James dash, Tom dash, Mark. Just you can change here. And also let's change another. Let's change this to star, for instance, star. So we can separate this string, and instead of comma, we can separate by this star delimiter. So let's see here. You see John star, James star. Yeah, you can do anything, but the requirement is comma separated. So comma, let me put back to comma. Okay, let's go to the second code, the second requirement. The second requirement here is, number 2, or starts with 1, or starts with other than 1, even not only 1, but other than 1. There is a code here. Let me uncomment this, and it's already uncomment. Let me uncomment here at the end of the block. Okay, now this code is live. So all starts with 1, or starts with other than 1. So here, this first code, this first line, I mean, you see this, the first line, list, integer list from collection, as I mentioned, Stream API is to process a collection, right? To work on data, to work on collection interface. So here, what does this line does? This line, this is input here. You see the input here, but create a list of integers. This line creates for us a list of integers, right? So what about the second line? This second line then, this second line, list string, starts with 1. This is a reference. Whatever you like, you can write whatever you like. It doesn't, but it has to define. It has to define the code itself. And numbers dot stream. So as we have seen above, these change to string, to string. It converts to string. Numbers dot stream, numbers comes from this reference, right? Numbers dot stream tells us that it converts to string API. So here, this code dot map string. This is method reference from the method reference in Java 8. If you can refer Java 8 method about the method reference. This is double colon, you see this double colon is from Java 8 method reference. So what does this line does for us? It converts each integer to its starting form. It converts each integer. These are integer, right? Each integer. 10, 23, 43, these numbers are integers, right? So each one of them, it converts each integer to its string form. So then let's go this filter. This filter method, this is the main code. This is the main line that defines the requirement. You see, so filter is this string, anything. You can use anything here. This is array. I mean lambda, str lambda, str the same, dot starts with. This is the method. Starts with. This is not integer. It's in the form of, you see, double quotation. It's in the number one is in double quotation. This is a string. What does this line does for us? It keeps only string that starts with 1. You can print only string that starts with 1. And the last line, this last line collect the filtered string into a list. It collects the filtered strings into a list. So and actually the last line, it's not the last line, but the last line is this printing line. Print each element of the resulting list. Each element of resulting list. It starts with 1 dot for each system dot out dot printed, and this is printing in a method reference way. So let me execute this code. It should, start with 1. You see his output 1, 10, 11. It starts with 1, 15, 1, 109. But the others here, 23 is not starting with 1. 43 is not starting with 1. But these 211 is not, 37 is not, but instead 11, 15, 109. These 4 actually, 10, including 4. These 4 elements, these 4 integers starts with 1. So let me print, let me run this code and you'll see. Okay. Okay, let me see. There is something wrong here. Let me see what was wrong. Yeah. So why is this int numbers? There are 2 codes here, right? So let me comment this for now so that we can run, because 2 different code. Okay. Now let's go to execute starts on this code. As you see, now we are here, right? We are here. So check each line. Create a list of integers using this line and convert each number to a string, filter those that start with this is not integer 1, but it is string 1, and collect them, then you can collect them. And also this line converts to string, and this map string, this method reference, convert each integer to its string form. And this filter starts with 1, keep only string that starts with 1. And the last is collect the filtered string into a list, So let me now print this code. Okay, just forget about John, James, Tom, Mark. This is from the other code. This is uncommented code, just ignore that. And you see here, 1, 0, 10, 11, 15, 109. This 2 is also from another code. I can comment those somewhere in this collection of code. Okay, let me, where is uncommented code? There's somewhere uncommented code. That's what it is returning here too. Okay, no problem, just that is the second. So you see here, print each element, the output is the same that we seen, right? 10, 11, 15, 109, right? Let me run it again. Is it 10, 11, 15, 109? Just ignore this John, James, Tom, and Mark, because this is from another line, another code. And this 2 is also from another code. Okay, now what did we do? What if I change these 2? One, you can start with 2 or different, like what? Let me change this one to string 2 in string form. Okay, let me run this code. You see now, it's bringing 2, 3, 2, 1, 1, 2. It starts with 2. You see, 2, 2, 2. 23 starts with 2. 2, 1, 1 starts with 2. 2 starts with 2. From this code, right? 23 and 2, 1, 1 and 2. This starts from 2. When you do, and you can change for any number, like 4. If you put 4 here, so it prints a number starts with 4. You see, 4, 3. I said ignore these 2. Ignore these 2 and John, James, Tom, Mark. This is from another code, but only 43 is the output of this code here. Okay, so that's it. Now let me turn back to number 1. It starts with 1 because. Okay, now let's go to the next code. Let's go to the next code. The next requirement is return non-null or is null. In output, let me uncomment this code. Let me uncomment. Okay, now that this code is uncommon. This code is uncommented, and there are uncommented code somewhere. Let me comment the code. It's not uncommented somewhere because it is. Okay. Okay. Okay, just you can ignore no problem. Let's go to number 3, return non-null or null. Now the requirement is, print return or print non-null or is null from this output. From this input. Like here, this first code, this first line, it creates a list. This is a list from collection interface, from array list. It's list. Create a list that includes some null values. There are null values, right? Apple, string, null, banana, null, orange. So if you want to non-null, means that is not null. That's not null. We can print not null, or we can print also null values from here. So that is what. And the second line, this line, you see this line, stream the list, filter out nulls, and collect non-null item into a new list. Now, in this case, it is non-null list to stream. It converts to stream. Now, what about this line? Especially the keyword here is objects. Don't forget these objects when you are converting to non-null or null. Dot filter objects non-null. This is also, as I said, it's a method reference from Java 8. So this line keep what? Only non-null elements. Those are not null. But then the last, this line collect the result into a new list. It collects the result into a new list. Then print, the last line, print in a way that's for each, for each. And here you see double colon, method reference way. So the output here is, apple, null, banana, null, orange. We are printing non-null. What are non-null here? Apple is non-null, banana is non-null, orange is not null, right? So apple, banana, orange, it should print this. Let's run this code. Okay, forget these lines, but apple, banana, orange. Okay, let me comment. Let me comment this line. Let me comment this line, this code, and also, comment this code so that it may not print. And also the first, also this code, number 1, let me comment this code too. Okay, let me comment this. Let me close the comment. Close comment. And the third, now we're working on all starts with 1. Let me comment this code too. When it is, now it's commented, but we started from from here. Okay. Okay, now we can run now this code. This is the only code that is uncommented. So as I said, return non-null or is null, right? So this line this line, list, string list, arrays as list. This is create a list that includes some null values, right? Not some null values. Apple is null value, non-null value. Banana is non-null value. Orange is non-null value, but null is null. You see nulls. So we are printing null values according to this code. The first, list string, non-null list, list dot string, this code. I mean, this line, it filters out nulls. It's stream the list, and also filter out nulls then and collect non-null items into a new list. That's what the whole code does. Here, this line, filter object. Don't forget these objects. Keep only non-null elements. And that this collect, this also, this line collects the result into a new list, not the other list, but the new list. Then print each non-null item in the new list. How? Here. That's in a way method reference, double colon. It's a for each system.out double colon printer, and this tells us this is method reference. But when the output is apple, banana, orange, right? Let me print this code and you see. Yeah, you see now? There is still somewhere uncommented code. It's printing too. But here, apple, banana, orange. Just ignore this number 2. We'll find it on our way back through. Okay, now let's go to number 4. The fourth code of the day is fourth code of the day. What is the requirement? Give this list use stream to find average. Find average in double. You print average, but print it in double. Of what? Of not prime number, of even number. Of even numbers. So out of these, you see here, let me comment this code. Uncomment. Okay, let me uncomment here. Let me uncomment this code. This line, this first line creates, you see, this first line creates a list of integers from 1 to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The list of integer. This is integer. It indicates here the bracket integer. The list of integers from 1 to 10. Then here this line, and even the other lines together stream the list. This line streams the list. It converts to stream. The list will be converted to stream so that we can process this collection of list. So then after it filter even numbers, in these filter even numbers. This is how you filter even number. This code, dot filter and lambda n person to is equal to 0. Equal 0. This keep only even numbers. How do you print even number out of this list 1 to 10? What are the even numbers here? 2, 4, 6, 8, 10. These are even numbers. So we are finding the average of these even numbers, but we print it in double. Data type. In double data type. Okay, so the last, this line, map to double, we are gonna print in double, right? So this is the line converts to double for averaging. Before we average, we have to convert to double, because it says in double here, right? In double. We are finding average of even numbers in double. So we are printing in average. So what line does that for us? This line. You see? What? 1.0. It's in a double format. N times 1.0. So it converts each to double for averaging. And the last line, this dot average line, it calculates, it calculates the average of the resulting value, right? Resulting value. If you, if you add 2, 4, 6, 8, 10, and divide these to their number, like 5, 1, 2, 3, 4, 5 to 5, you can add up, 2 plus 4, 6, 6 plus 6, 12, 12 plus 8, what is 12 plus 8? 20, right? 20 plus 10, that's 30. 30. This 30 is these 5 numbers. The sum of these 5 numbers is 30. So to get the average, you have to divide to the numbers, right? How many numbers? How many numbers made 30? Like 1, 2, 3, 4, 5. So 30 divide to 5, that's 6. But here you don't have to, the output is not just 6, but it should be 6.0. Why? Because double. It's in double. We have to print it in double. So let's print it and see what it gives us. Okay, let me print this code. Yeah. Okay, let me uncomment first. Uncomment this line, the first. Okay, this code we already. Let me uncomment this so that you don't see the value here. Okay, now let's run this code. You see, just ignore 2. It's coming from somewhere. That's from uncommenting. But the output of this code, see here? The output of this code is 6.0. We printed in double. The average in double. So that is what each line does. So this is very important. Every interviewer asks you how it works. Not just, memorize the lines, memorize every line, and just do your code. No, that doesn't not work. Every interviewer asks you what each line does, what each code does. So the functionality you have to know. That's why I'm trying to explain what each line does for you. Okay. Let's go to so okay, here this is another way. This is the other way of using the same code, Now let's go to number 5 instead of. Okay, you can try this. There are a slight difference, but it gives the same code from the above. You see here, maybe how you safely print the result, right? In above, Okay. Here, you see here how we printed the same code. The same code how we printed. Get as double, right? That was how we printed. But here, to print safely, in case it doesn't present, in case it doesn't present for safety purpose, the other version of this code, the same code, but the other version of printing the average in double of even numbers. You see here? So safely print the result. You see average dot if present. If present, this is very important. Safe. If present. What if it doesn't present? Then it doesn't throw an error, doesn't throw an error. So this safely printing is very important, and you can learn how safely can you print. In some cases, the above code may not work. If you just use print system.out println, just print, it may not work. Sometimes some code requires safety, so you can safely print the result if you are using this. And there is another way that the other version of the same code, I tried to put in 3 different ways this code. This is the same. Actually, the content is the same here, but optional double average numbers string, you see, optional double, this is a slight different. So you see, this prints the same 6.0. So I'm not gonna, already we've seen, and now let's go to the 5th code of the day. The 5th requirement is Java programming to count the occurrence of each character in a string. Each character. I mean, here, Java programming to count the occurrence of each character in a string. For instance, here, the first code, here, this line, you see this line, is the input. This is the input string. This is the input string, without space. All characters, all characters will be counted, all characters. This counted. JAV, Java, boot, Spring Boot, Java, boot, Java. There is redundancy here, right? Repeated. How many times? How many times each character is repeated? That is to print each character, how many times it is printed. How many times it is repeated. That is what we are gonna do. So you see, string input. This is string input. And so this line, let me uncomment this code. And let me uncomment this code so that we can run it and check. You see here? So it is string input. This string input. This is string because it is in quotation, right? It's string. So this line, what does this line does? Map character long. Map is equal to input dot cars. Instead of, it's not car, it's not in other code we see input dot stream, right? But this is different. We are converting string to int stream of characters. Int stream of, we are converting a string to int stream of character codes. That's why. So this line converts the string to a stream of characters. But we don't need to say just string, right? A stream of characters. Then group them according to, and then count their frequency. That is what each code does. So what this code does, this line, it converts each int, you know, it converts each int. That's Unicode actually, right? When we say int, that's Unicode. For instance, 95, 96, each character has, integer equivalent, right? Integer equivalent, that is Unicode, to a character object. We are converting this each int Unicode, for instance, J maybe 95 or 96 or, Unicode. So we are converting this to a character object. Then here all together, that collector starts grouping by. So the main thing we should remember is grouping by is a method. Grouping by is, grouping by method here. Then function.identity and collectors.counting. So, this line group by the character itself, it groups by character. Then it counts occurrence of each character, counts how many. This line collectors.counting. So this whole line, what does this all here does for us? It group the character itself. It's group to make it to group. For instance, 1. Then it group and counts. For instance, what does it mean? It groups J's, all J's to 1, all A's to 1, all V's to 1, all S to 1, all P to 1. And then the last, collectors.counting does for us is it counts. So then finally print the character frequency map. Frequency. Here you see map to object. Why we are converting this to map here? Convert each integer to map, or to object. Why to object? Because in this collectors method, we cannot use primitive data type. That's why we are converting this to object or string. Object or to string. We cannot use in collector class, we cannot use, but we have to convert it to string or object. That's why map to object here. This is how we convert to object. This is how we, primitive to object, or primitive to, string. String can be used and object can be used, but primitive cannot be used here. So this line, what does this line does? It groups. You see, grouping by itself. Grouping by method is, the Java 8 method. One of the methods, it groups. Here it groups by, it may group in, according to the code content there. But here function.identity it group the character itself, then collectors to counting. These count occurrences of each character. How many times it occurred? How many times each character, as I said. So this line prints. It prints the output, and we see here A is 5 times, B is 2 times, G 1 times, I 1, J 3 times, N 1 times, O 3, and so on. Let's print and see. It has to, we have to see this when we print or execute the code. Execute this code. Okay, this code. So when we execute this code, our output is the same to this. Should be the same to this. Let's see. Let me print. Okay, yeah, you see. Ignore 2, as I said, ignore even 6. Okay, let me first uncomment at least 6. Okay, let me uncomment. Okay, let me uncomment. I think number 4, yeah. Here, number 3. Already we've seen this. Let me uncomment. I think that's it. Okay, here too. Let's uncomment here, please. I mean, comment. Okay. Then all are commented, but except that printing too. Okay, now this line is what we're working on. I mean, this code is what we're working on, the occurrence. How many times it occurred? Each character from this input. Let me run this code. Okay, just to ignore these two, P how many times? 1. Okay, let's see if P is 1 in this program. Let's see. You see here, Java, Spring Boot, Java, Boot Java. There is only one P, right? See here? So P is 1. P is repeated just once. What about A? A is repeated 6 times. Okay, let's see A. Let's count A in this input. A1, A2, okay, go. A, you see here, A3, A4, A5, A6. It's repeated 6 times, but others are also, you can count B 2 times, R 1 times, S 1 time, T2, V3, G1, and these are, and so forth, Okay, let me comment this code and proceed to the next. Let me comment so that it may not print here. Okay, now let's go to 6. The 6 is a duplicate, how to duplicating code. Actually, we are using the above code. You see here, let me uncomment, yes, and let me uncomment somewhere here, uncomment here, and explain what it does. Okay, why do we see this error here? Because we don't have what here? We don't have the input here. You see, we don't have input, but let's use the input from another code, and we uncomment that input. Let me uncomment this input, and we can use for the next code just this, or else I can bring that again to the other. Okay, then comment, doesn't matter, just comment it and bring here, because it should have input to print this code. Okay, let me, okay, you see, okay, let me, yeah, this code is, let me comment it. You see it, now the error is gone. Okay, now we are working on this duplicate. So on duplicate, in duplicate, what we are doing is just changing this greater than or less than 2 or 1. If 2, you know what, we'll see what happens. But let's see each line. We are working on duplicate, you know, if it is not, how it is, you know, what to use not to duplicate and what to use to duplicate. This is string input. This is the string input. You know what the code does is it split the input string, split all this input into individual A to A, V, individual characters, and process to find duplicates, you know, or not to duplicate. So in the first, this code, after the input, this code, arrays.stream inputs, all right, split. So what does this does for us? It converts the string, it converts the string, right, to a stream of single characters. It converts the string to a stream of single characters. Then what about this whole line? See, this whole line, what does this whole line? Is just it grouped by the character itself. You know, grouping does group by character, then function identity, collector stuff, counting. It counts how many times each character appears. And then this line, and then this line, it converts the map to what? Entry set, right? Entry set is kind of map, you know, one of the functionality, one of the methods of map. So it converts the map to a stream of entries. It converts the map. It converts the map to a stream of entries. Chart to count, you know, chart to count. And this line is a filter. These filter characters, you know, it filters the characters that appear more than twice. More than twice, not twice, but more than twice. That are the characters we expect to be printed more than twice. Greater than 2, right? Greater than 2. What about greater than 1? We expect 2. The characters which are equal to or greater than 2. So what about here? This code extract the character extract the character and get key from each entity, you know, from each entry, I mean, it get, you know, from each. And the last line, what about this? The last line, collectors to list. It collects the duplicate characters into a list. These collect the duplicate characters into a list. So then finally, it prints, right? Print the list of duplicate characters. But here it is different. There are some explanations. The output is duplicate characters A and J. If A and J appears more than twice, right? A and J. A and J. A 6 times, right? J 3 times. So it's greater than 2 because it appears 3 times. J appears 3 times. And in this input, what about A appears 6 times? So it is true, it's greater than 2. But what about less than 2 is different. We will see what to print. Let's print and here. And in case if the character is uppercase, you can use to lowercase, you can change to lowercase on characters if case sensitivity check is needed, or change 2 to 1 if you want to count any duplicate appearing at least twice. At least twice. You can convert here 2 to 1 or another way. Okay, let's print this code and check what it gives us. You know, here duplicate characters A, V, J, O. These are more than 2 times. Ignore these two. Ignore these two. But duplicate characters are A, V, J, O. These 4 characters appears more than or equal to 2 times, right? Let's see. A, V, J, O. A 6 times, J 3 times, O how many times? Good. 2, 4 times. O 4 times. And then T. It's not right actually. Just you don't need this. Okay, now this output you can see, you can run the code and see what the code is. This is the output. So the output is, you see duplicate characters A, V, J, O, more than twice. More than twice. But what about if I change this 2 to 1, greater than 1, greater than 1, greater than once? That means 2, right? Let's see, greater than at least 2. You see, A, B, T, V, J, O. These prints greater than, A, it adds, right? All A, all O, all J, all V, those are 3. But these prints, this increases, you know, increases the print, right? More than 1 time. 2 and 3 times, 4 times, 5 times, 6 times. But what about if we change this less than 1? Less than 1. Let's print and let's check. Less than 1 is nothing, right? Okay. What about is equal to 1? If something is printed to 1, you see, I made it equal to. Okay, let's see. PRSQIN. P how many times? P just 1 time, right? P is just 1 time. R how many times? You see, only one time. R is only one time. S is only one time. And Q is only one time. I is only one time. N is only one time. These are just in this input. These are only appears just once in the input, only once. So how do we get that? Just changing is greater than 2, greater than 2, equal to, right? The same code, but just manipulating here, we can get different result. Or maybe what about greater than 4? Maybe greater than 4. How many? Maybe 1. Maybe, okay, let's see. A may be the only one. Yeah, you see A, because it is mentioned 6 times. 6 times. A here, yeah, 6 times. Here A appears 6 times. That's why greater than 4. Or what about equal to 4? Equal to 4 is equal to 4, 0. I mean O. Yes, O is 4 times, right? Let's see. Here, O, 4 times. So that is how you can retrieve different, how many times it appears. Okay, let me change to the original, greater than. Okay, this is how this code works. Now let's move to, there is another version of the same code, but slight different. There is a slight difference, but you can check by yourself this code. I mean, because it is already recorded here, another version, you see, it's recorded here, but there is a slight difference here. Maybe how it prints is different, and also there is very slight difference from the one we've been working on. So it's another version actually. I'm not gonna go through this, and you can check by yourself and practice for your next interview. Okay, now display the first non-repeating character. Non-repeating, the first. What does that mean? Non-repeating, just occurred once. Just that's occurred once. Okay, let me use the same code. I mean the same input, right? Okay, this, let me run it. Okay, this is different code. Okay. Okay. Let me separate this code for you. This is the above. Is the okay. This is the 6, but it is still the same repeating type of code, but it is the same. I'm not gonna go through this code too. You can check by yourself. This, it's the same to above code, but yeah, I used is equal to 1 instead of greater than 1 or greater than 2 here, but it does the same thing. So the same code, I was just making it another version just to separate greater than 1 or equal to 1. That was the only time, how many times it appears in the from the output. Now we are gonna go to different code to find the second highest number. This is many times, it's very frequently asked question. It's frequently asked question. Java program to find the second highest number from a given array. This is in the context of Java 8 Stream API. It's not in loop or another Java 7 or backward Java usage. It's not from there, but it's Java 8. Now, the input here is, okay, let me uncomment is, first of all, let me comment the above code so that it's comment, okay, yeah, it's commented, okay. Okay, let me uncomment this code. Let me uncomment this code. Okay. So we are working on, okay, let me, here, you see, from this code, from these int numbers, from these primitive int numbers. So which one is the second highest? Not the first highest, but the second highest. 21 is the first highest, right? It's easy to get the first highest, but it's a little bit tricky to get the second highest. So what is the second highest? Not 8, not 9, but 11, right? To print 11 is the second highest, not the first highest. 21 is the first highest, and 11 is the second highest. So how do we print the second highest from this int from this primitive integer, primitive int? So we are gonna here in this line. Okay, what do we do in this line? The first line here. So the whole code does for us is creating a stream from the primitive int array, convert to boxed integer, sort and collect as a list. That's the whole thing what we are gonna do. But when we see the line by line, the first line, it converts primitive int, right? Primitive int array to int stream. So int stream is, you know, what we are converting our primary, our primitive int here. So boxed, I think you have an idea, boxed and unboxed, right? Boxed and unboxed. But here, boxed is boxed each int to integer object to work with, you know, to work with as I think we have discussed this above, right? To work with collectors. You cannot work, you know, with collectors with int. So you have to change it to, you have to unbox int. These are all int, right? But you have to make them integer. When you are making them this integer, you are boxing. But back to unboxing is int, but it's changing to primitive, right? Primitive int. So with collectors, we are not working with, but we are working with object, or it's integer, you know, object or integer, only with object. So it's collectors anywhere with collect or collectors. You can use is just, you can, if you need, you have to boxed, but not unboxed. So here, this sorted, it sorts this sort the stream in natural order. You know, the natural order is ascending order, right? Ascending order. You know, ascending order is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is, you know, ascending order. But 10, 9, 8, 7, that is descending order, right? So here, let me see this line. Collectors to list. This line. Collect the sorted integer into a list. Collect the sorted integer into a list. It's very, very important. And the last line, you know, the last line, print the sorted list of integers. You know, now let's print this code. We'll see what it says. Yeah, duplicate characters. These characters. I haven't. Let me uncomment our first code. It's not uncommented, right? It's not uncommented above. Yeah, here it is not uncommented. That's what it's duplicating. Okay, let me comment. Let me comment this code so that it may not disturb us printing. Okay, now move to the same code that we are talking about here, right? Int array numbers. This is a reference of 5, 9, 11, 2, 8, 21. So we are looking to print the second highest. That is 11. Okay, 11. So how I've already talked about this. You know, we create in this all code. What we do is in this all block of code. In this all block of code, what we do is we create a string from the primitive int array. Int array is, you know, that int array numbers 5, 9, 11, 2, 8, 21. This is int array, right? Initialized int array, right? Yeah. And convert to boxed integer. Convert to boxed integer. That is sort and collect as a list. So what we are doing is, you know, list integer list, arrays dot string, here numbers. So these tells are convert primitive int to int string. You know, int string. It's one of the methods. And also you see here boxed dot boxed. Why we are boxing here? Because this is primitive. This primitive has nothing to do with collectors. When we are working with collectors, we should change this to object. So how do we change to object? We have to boxed, you know, integer in place of int. In place of int, we say integer. When we say integer, we are boxing or converting this to object. That's object. Integer is object, right? So this is integer object, right? To work with collectors, we need to convert this and then sort this line. What does this line do for us? It sorts the stream in ascending order. We'll see later descending order, but this is ascending order, natural order. That is, you know, 1, 2, 3, 4, 5, that way. And then this line, what does this line does for us? This line, you see this line everywhere, right? Collectors dot to list. It collects the sorted integer. It's sorted above, right? Already sorted above, and it collects the sorted integer into a list, just list. Then we print that list here. We print that list here. So let's print that list. Yeah, you see, ignore these two. As I said, you see here, 1, 2. Okay, this is just the sorting order. We are not printing 11. We are not printing 11 here, but what we are doing here is we'll print 11 later on, right? But before that, we have to show you what the ascending order and descending order. This is the ascending order, right, of this integer. This integer, how we entered is different, right? First 5, then 9, then 11, 2, 8. It's very mixed, right? It's very mixed. But here it is in ascending order, right? 1, 2, 5, 8, you see? 9, 11, 12. This in ascending natural order. We converted this to natural order using just this code, this whole code. Yeah, this whole code does is convert this number to natural number, printing this number to in a natural or ascending order. And the next, the same code, but the same code, you see here. Okay, let me comment this. Let me comment. Okay, let me comment. Okay, I commented, and let me uncomment this code. The same code, but the only slight difference is what? Let me show you. The only slight difference is here, inserted. You see here, comparator. So here, comparator dot reverse order. You know, comparable and comparators. You know, you have to know about comparator and comparable methods, what they does. But here, comparator dot reverse order, that in ascending order. We just changed this. It was just sorted, right? If we move this line, okay, if we move this line, the same code, right? It's the same as the above code in ascending order or in natural order, printing in natural order. But here, if we add just this, okay, comparator, just adding comparator dot reversed order, this converts this code to descending order. So let's print this code. We'll see how descending order starts from, you see here, 21, descending order, 21, and 11, 9, 8, 5, 2, 1. So we are gonna use this descending order to get the second highest. That's why I'm just trying to show you this first. So in our next code, what we are gonna do is we are gonna get the second highest. How? How are we gonna get the second highest? Find the second highest number from the array. But you have to convert this to comparator reversed order, to descending order. Then skip one and find first. These are the very important lines, very important lines to convert, you know, to find the second highest. How? Okay, let's start line by line. Find the second highest number from the array. From which array? The array which we have been working on, right? It is this array. int array numbers 5, 9, 11, 12, 2, 8, 21, 1. That's why it's not commented here. We are going to use in the other code. So, okay, let's see. Okay, let's see. Let me first uncomment this code. Let me uncomment this code. Find the second highest number from the array. Integer second highest number. This is the reference. Whatever you can use any. You can write any name or any name. This is just name. Arrays dot string numbers. Right. What does this does for us? The first line. This line. The first this line. What does this line does for us? It creates a string from the int array. From the int array, that is the input we have above. It creates a string from the int array that we have, right? I haven't written here. So if you like, I can write. Let me bring that int array to here so that it may be very easy for you to compare. Okay, I will take this int array from here, and comment it here, or start the commenting from there. How? Okay, start from here. Okay, now let me go back to our code and give the array here. Let me copy, let me paste. Okay, here from this array, we are working on this int array. So integer second highest number. So this converts a string from the int array. So this line converts to int array. Int array. From int array to string. You see here the string, and then boxed. The second line boxed is the same thing that we have been discussing, right? Convert each int to integer object for a string operations, right? For a string operations. What does that mean? It doesn't, we don't use primitive int with collectors. That's why we are converting this to integer object. And sort, you see this line is very important. It converts to this int array to descending order. It sorts by descending order, in reversed order, not in natural order, but reversed order. Then skip one. What does that mean? Skip one. Skip one is skip the first highest element. Skip. Do not include the first. From this, you printed in descending order, in reversed order. When you reversed order, skip the first highest. What is that? 21. Skip. Don't include 21. Do not include 21. The first highest. But we are printing the second highest. So find first. You have to find first and skip. Find first and skip. Then get the next. Yeah. So what does this find first means? It get the next element. Get the next element, which is the second highest. Yeah, which is the second highest. Then get. What does get does? It retrieve the value from optional. Assume non-empty input, right? It is non-empty input. And so let's print the second highest number, system.out.println second highest number. Okay, let me run this code and we'll see what it gives us for us. So the result should be 11, not 21. You see here, these two, ignore these two, but 11 is the second highest number. Do you know how to get the second highest number? Coding that generates the second highest number. So this, you know, in any project you can use this. In any project, you know, as you can use stream, but how to get? You have to convert this to descending order, and then skip one and find first. Then it prints. That is why I showed you above. That's how you can print in ascending order and descending order. That's very important. Easy way to convert your code. Okay, what about now? We're coming to finish, and we have maybe one or two more. We'll see. Okay, find the longest string from a given array. And also the shortest, just using greater than or less than. Define. Let me uncomment this code so that you can see. An array, a string array. This name, string array. See, Java, Docker, Spring Boot, microservice, Java, program language. Which one is longer? Java is shorter, Docker is longer. So this is longer, right? Java program language is longer. The characters here, it's longer. Java programming language is longer. So how do you manipulate? So how do you print this longer from this string array? So here, the first line of the code, shows us what? Use stream reduction, right? Stream reduction. Use a stream reduction. Reduces the method reduction to find the longest string in the array. The longest in the array. So the reduce method is very important. That's why we are converting this longest string in the array. So we are using a stream, right? Arrays.stream. Yeah. So this line converts what? The line that I showed you convert the array to a string. Yeah, a string. It converts to a string. This line. Optional is, you know, in Java 8. Here is it. Long string. You know, optional. This optional in Java 8. It gives you safety of throwing, you know, this avoids throwing null exception, null point exception, you know, any null point exception. If there is a null or something, you know, it helps. You don't face exception or error because of this optional. In Java 8, this optional helps to avoid null point exception. So it's very important. So the method, this line, as usual, it converts to array, to a string, right? String. But what about this line, reduce? Okay, this is the keyword reduce. To get longer, reduce, apply a reduction. That's the method. That's the important method. Apply a reduction to compare two words at a time. You compare two words at a time. So which one is longer or which one is shorter? The length of two words you compare, and the whole line. This whole line are the same thing, right? Ternary operator, this is greater than, this question mark, and word one, this semicolon indicates that this is ternary operator is also used here. Ternary operator is used. So keep the longer word in each comparison, right? That is what this line does. So this from reduction to here is very, very important, right? It apply a reduction to compare two words, and also keep the longer word in each comparison. So I think let's print and see what is the longest from this using just this code. Is it just using this code? Okay, just using this code. What's the longest? It should print Java programming language. That's the longest of all three, all four here, right? You see here, Java programming language. Why is this 11 printing? Because I haven't commented the above code. Let me comment it so that we may not see. Okay, let me comment it. Let me comment this so that we may not see, clearly see. Okay, now let me run the code. You see here, Java programming language. This two is, ignore these two because these two is from uncommented, another block of code, different code. So it's printing from somewhere. But here, Java programming language is the longest of all here. That is what it is printing. Okay. Yeah. Okay. Now, okay, this is the line we have been working on, right? The block of code. The block of code we have been working on is this, right? Find the longest. So from this string array. So this, we printed this, right? Java programming language is greater than microservice, longer than microservice. And Java programming language is longer than Spring Boot, longer than Docker, longer than Java. For characters, it's of the length. So we compare the first word one and word two, and then the length of word two using ternary. Okay, when you print Java programming language, let me print it again. Java programming language is the longest. So there are different programming that functions, different programming. That's very important. Okay, let me comment this so that we may not face problem in our next coding. Okay, now here, let me comment. Okay, it's commented, so now we are not gonna print it. So this code, you see, we have already done this in our program, right? Find elements, start with number one. dot map here starts with number 1. We have already seen this, and we're not gonna repeat this, or you can check this above. We have already worked above. And now we're gonna check another code, join method. Join method. This code will, I think, not commented and causing printing that number 2. I think this is the code that doing number 2. I found it now. Okay, now let's see. This is string join method. So what does string? Create a list of string numbers, right? String numbers. Let me uncomment this code. Let me uncomment so that we can run. Okay, you see here, create a list of string numbers. List string, list 1, arrays as list, number 1. This is not integer. This is just string. String 1, string 2, string 3, string 4, right? But list string. But now we are gonna join, join the list elements, list elements, right? These are list elements into a single string, just separated by this comma, by separating it, just joining them. So string results, string dot join. We are joining. We are gonna work this join elements with comma as the delimiter, right? This join, this line, the whole line joins elements with delimiter. This using this comma as the delimiter. Then it prints. It's very easy code, the easiest one. You see here, string join method. This code is very easy. What does it do? Anything that is commented is just commented to learn. So this line create a list of string number, right? Just this line. It creates what? Create a list of string numbers. 1, 2, 3, 4. These are not, primitive ints or integer. They are just string because of the quotation, So join the list element into a single string separated by this code. The string result is equal to string dot join, right? You see this is a delimiter. This list 1 comes from here. The name of array comes here too, right? But this is a delimiter that comma join elements with comma as a delimiter, right? Yeah. Then it prints the final join the string. Now let's print this code and see what prints for us. You see 1, 2, 3, 4. It was written in string, but it changed to int comma. So this is done by join. It joined the elements. Okay, now let me write here at the bottom. You see here 1, 2, 3, 4. So that is what join does. Okay, let me comment this code. Let me comment this code so that we may not print it. We may not print this line. Okay, now skip and limit example. We are gonna see a skip and limit example. That's very a wonderful, very useful code also. Here, let me uncomment first so that we can print this too, this code. Okay, you see, into stream, range closed. You can say, you can use range also, range closed, and you can study, for instance, okay, let me show you the methods here. You see here, the different methods, range closed, range, but you can get the same result using this range. But now we are using range closed. That has argument industry, you know, yeah, inclusive. So now we are, let me click this, range closed. So here 1 to 10, range closed is 1 to 10, right? You know, this generates a stream of integers from 1 to 10. That is very inclusive, 1 to 10. But when we use dot skip, dot limit, and then this line prints, right? You know, what does this skip? One does skip the first element. Skip from this 1 to 10. Just consider 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 1 to 10. So skip the first element. This is skip the first element, which is 1, right? In this list, 1 is just the first element, but you skip that. But print limit just 1. Print just 1. That's what you see. Limit the stream to just the next element, 1 element. Print the single remaining elements here. For each system dot out, print element. Okay. Now let me run this code. You will see what it gives. Okay, there is uncommented here. Oh, you have to add this. Yeah, okay. Okay, now let's print. You see, 2. Skip 1. Just when you skip 1, the first element that you skip 1, and limit 1, the limit 1, just 1 number, only 1 number, that is 2. When you skip 1, just press, you know, from these inclusive numbers, 1 to 10, just print 2. That is, okay, let's change these to 5 and these to 5. Okay, we'll see the different result now. Okay, 5 to 5. See here, skip 5. From 1 to 10, skip 5. How many? 1, 2, 3, 4, 5. It skipped 1, 2, 3, 4, 5. Now starting, you see, 6. And limit 5. 5 numbers. How many 5? 6, 7, 8, 9, 10. How many numbers is that? 5 numbers here. 1, 2, 3, 4, 5. 5 numbers. Just limit to 5 numbers. Print 5 numbers. Skip 5. Skip 1 to 5. You know, 1 to 5. This means. Okay, skip 8. Let me 8 and print 5. Just 5 numbers. Okay. You see 9 and 10. Skip 8, but limit to 5. But we have only 2, right? It's 10. It's not gonna print 5 because we don't have that in the range. In the range closed, we have only this number. So let me say 3 and 3 so that you can understand it very well. Okay, let's see. You see here 3. Skip 3 means 1, 2, 3. 1, 2, 3. Skip limit 3 means how many numbers you are printing? 3 numbers. 4, 5, 6. These are just 3 numbers. Okay. What if you don't use limit? You can use limit. For instance, 9. Limit 9. Then what's gonna print for us? You see? 9 numbers. But starts from 4. Why? Because you skip 3. Skip 3 means 1, 2, 3. These are 9 numbers. 1, 2, 3, 4, 5, 7 numbers, because there is no 9 here, limit 9. But if line, then you can do 9 too. Okay, this is the whole for today. And next time we are gonna work on another code. But remember this is very, very important in print limiting numbers and manipulate this from this code. And thank you very much. And if you subscribe to my YouTube, when you get so you are gonna get very advanced code with explanation and very good interview codes. Not only codes, interview questions on core Java, any new Java, and Spring Boot, REST API, and microservice, and other technologies too. Thank you very much. I appreciate, and have a blessed day.